Okay, so from chapter 13, your assignment is going to be number 1 and 6. 6, not the entire thing. So I'm going to set it up. There are multiple parts of number 6. So I'm going to do the first part in which you guys sort of see how to get started with a problem like this. And then you guys will be doing the rest of it. And 1, you guys know what 1 is. Those statements that you have to agree with, explain, or whatnot. So in this video, we're going to be solving therefore number 2 and then part of 6. So let's get started with 2. We have the price setting relation, which is price equals to 1 plus m w plus a. So this is the equation that we had first seen in chapter 7, and we've modified it in this chapter by introducing the productivity coefficient, which is a. And we also have the wedge setting relationship, which is AE PE 1 minus U. So once again, this is also the relationship we have seen before in chapter 7, and we've modified it by including the productivity or the technology coefficient down here. Okay. So the question says, part 1, it says that solve for unemployment rate if, so price is equal to expected price, but expected technology is not equal to technology. Okay. As a result, what will be the unemployment rate? Okay, that's pretty straightforward. We start off with the price setting relation, which is 1 plus m w by a. From here, you guys know what to do. We find the value of this, which is real wage, which will be equal to a divided by 1 plus m. That's the price setting relation. And now we move on to the wage setting relation. Remember, we've been told that P is equal to expected price. So therefore, from that relationship, we get W by P is equal to expected technology, 1 minus U. U is, of course, unemployment. And now you see that this and this are equal, so we can combine them. We get A 1 plus m equals to AE 1 minus U. Or if we simplify it, we get 1 minus U is equal to A by AE times 1 plus m. So this is 1 by U. We have to find unemployment, so just U. So U will be equal to 1 minus 1 by A plus m times AE. But of course, we can simplify this a lot more. And if you guys want, you can write it in this form. AE minus A divided by 1 plus m AE. Okay. It's fine if you write it in this form. It's obviously not wrong. But I think that this is easier to interpret. Okay, so I'm going to leave it at this stage. Of course, you guys are free to do what you want to. So unemployment is, let me just write this down again. Unemployment is equal to, rate of unemployment is equal to 1 minus. So we have this, which is the markup. And of course, as the markup goes up, unemployment also goes up. We knew that already from chapter 7. And now we have, in addition, AE. Okay. And the question is, in part A, explain the effect of this on unemployment rate. Okay. So in this equation right here, what happens when the value of this goes up? When this goes up, what happens to unemployment? If this is going up, let me get the thing. So when this thing is going up, we know that this thing is going down, And when this is going down, we have a 1 minus that, unemployment is going up. It's going up. So the question might be, why should this be? So let's first interpret what this means. So if AE is greater than A, expected technology is greater than what technology is, that means that technology has not grown or progressed at the expected rate. We were expecting a certain level of technological progress to take place. That has not happened. So technology is worse than what we had expected. If technology is worse than our expectation, remember what will happen. If you expect technology to grow, you negotiate with your employer, and you also you increase your wage. If technology is expected to grow, wage go up. However, if technology, that level of technological progress does not take place with high wage, what will happen? Employers are not getting the level of production that they were expecting, but they have to keep paying you a higher wage. As a result, what is going to happen is people are going to lose their jobs because farms are making a loss now. They were expecting high technology. As a result, a certain level of production. They're not getting that level of production, so they're not making enough money. They cannot continue to keep paying people the higher wage, but that contract has been signed and wage cannot go down for now. As a result, people lose their job. When people lose their job, unemployment goes up. So that's the explanation. When, of course, when expected technology has been higher than with the technology we see in the economy. However, in this case, when the technology in the economy is higher than expectation, the exact opposite will happen. And I'm sure you guys can work out what happens in that scenario. So I'm leaving that for you guys to do the next level. We'll move on to part B, which says that, okay, so first of all, it says that P is equal to expected P and A is equal to expected A. So that simplifies our task. And it also says that M is 5%. So markup on goods is 5%. We have to calculate the natural rate of unemployment. Okay. Natural rate of unemployment is given by this equation that we have already calculated. So that is 1 minus 1 by, 1 plus M AE. Now we know that A is equal to, we know that A is equal to AE. So this cancels out. We are left with UN equals to Y, 1 minus 1 by 1 plus M. M is 0.5, 0.05, is it? Yeah, 5%. And if you just take out your calculator, what you will see is that this gives us 1 minus 1.05 equal to, I think we get something like, let me just use my calculator, 0.0476. Or I can just write that natural rate of unemployment is 4.76% or 4.8%, whatever. Okay, simple calculation, that's part B. Part C. Question is, does the natural rate of unemployment depend on productivity, which is A. Okay, so here's the thing. Pause the video. Think about this. I'm going to be solving this, talking about this right now. But before you look at my explanation, pause this video, think about this for at least at least 10 minutes, unless you're sure you have the right answer. Okay. Does natural rate of unemployment depend on productivity? Okay, so hopefully you guys have had a think. This is the equation that we had. Okay, 1 plus m times a. Now, it may look like un definitely depends on a because we have this here. So of course, if this changes, this will change. But that is not technically correct, because what really matters in this case is expectation. So if our expectation is correct, then what happens is this entire part cancels out. This is not relevant anymore. This is the part that we have to focus on. Productivity only affects unemployment when our expectation is wrong. And that's when productivity plays a role on unemployment. So the answer will be, of course, in one word, no. But that is because the natural rate of unemployment depends on a variation or difference between actual and expected productivity. If expectation is correct, which is basically if A is equal to AE, then what happens is that real wage adjusts. As we've seen, there's going to be negotiation. And if you expect technology to improve or become worse, you're going to adjust your wage accordingly. So wage adjusts, and there is no effect on the natural rate of unemployment. So this is important. This is a little tricky, I understand, because obviously it seems like, of course, productivity will decide how much unemployment or how much employment there is in the economy. But if you anticipate this change in productivity, if you see it coming, then you adjust, the other economic variables like wage and whatnot. Only when we make a mistake in our expectation do we see the natural rate of unemployment going up or going down. Okay. So that was part C. That's the end of question 2. So now let's move on to number 6. And as I said, I'm not going to be doing the entire 6. I'll just be doing part of it. I'll be doing part A, and then part B and C are explanations, which you guys will be doing. Okay. Let's start with 6. So once again, we have the price setting and the wage setting relations. P equals to 1 plus M W by A. Wage equals to expected E, expected U. And of course, we have this, we've seen this equation as well in 7. Number of workers or employment is equal to 1 minus unemployment rate times number of workers available. Okay. What we have to do is we have to derive, see question 6a, we have to derive the aggregate supply curve. What that means is the relation between price level You have to basically find relation between price level with the level of output. Okay, that's what Y, I suppose. Given the markup, the actual and expected level of productivity, the labor force, and expected price. Okay, you guys don't have to write this down. I'm just doing that for simplicity. So, okay, so we take this 3 equation, and what we do here is, let's see what we have here. Oh, sorry, I forgot to pause the video. Okay, so I forgot to mention one thing. This equation right here in number 6. So we actually have 4 equations. Okay, that makes sense. We also have y equals to an. This is the production function, remember, that we had seen before I don't remember in which chapter. So from here, now it makes sense. From here, what I'm going to do is I'm going to find A, which is, or let's say find N, which is equal to Y by A. Okay. So P here is equal to 1 plus N W by A. But I can replace this with, what can I replace this with? 1 plus M will stay, but wage is equal to AE PE 1 minus U divided by A, which is P 1 minus U. So up here I know that 1 minus U is equal to N by L. So let's put that in, 1 plus M AE PE 1 minus U is equal to N by L. This whole thing divided by A is equal to P. And now I can substitute N. So what I will get is 1 plus M AE PE. N is Y by A, and we have L A, which is P. Now A and A cancels out, and what we are left with, hopefully I have this correctly, 1 plus M, or actually I'm not going to cancel this out. So I'm going to leave A here, and I'm going to leave A here. So what I am left with is AE A times Y divided by AL PE. Okay, let me just write it down better. Price equal to expected price times the markup times the productivity coefficient. This. Okay, this is our supply curve. And this is exactly what the question wanted. So if you read the question, the relation between price level, level of output, that's right here, given the markup right here, actual and expected level of productivity here and here, the labor force right here, and expected price. And this is of course here. So this is exactly what the question wanted us to find. Sorry. Okay, so what does this mean? Okay, this should make sense to you straight away. For example, let's go step by step. if expected price goes up, what will happen? People expect the price to go up in the future. Workers will renegotiate, their wages will go up. When wages go up, companies will increase the price of goods. So we see a positive relationship. What about M? If M goes up, what does that mean? That means that firms have more control in the economy, in the market. If they have more control, they will charge more price, a higher price. So price goes up. What happens when technology goes up, or rather in this case, when A is higher than AE, when the progress in technology that we were expecting has not happened, what will happen in that case? In that case, firms will not be making as much profit as they would have expected, but they're paying a higher wage. So what they will do is try to increase the price. As a result, price will go down because the technological advancement hasn't happened. So price goes down. So once again, if when A goes up, B goes down. So these are the different relationships. So what you guys have to do in the final part of part A is explain the role of each variable. So basically explain how PE, M, AE, A, Y, and L affects P. Okay, I've done the derivation. You guys do the explanation. That's in part A. And then part B and part C, once again, I'm going to leave for you guys. So that's, there's no more derivation left. All you guys have to do now is just basically explain this, okay? I've done the derivation. You guys try to find explanations of what happens when different things in the economy changes. So in part B, show the effect of an equiproportional increase in A and AE. So what happens is A goes up, AE goes up. So the ratio of AEA stays the same. Let's say they used to be 100 by 100. Now they're 120 by 120. So the ratio has not changed. The ratio is still the same, but their values you see 100 to 120, 100 to 120. Their values have gone up. If this happens, what happens here? That's in B. In part C, suppose instead the actual productivity increase, but expected productivity does not change. Okay. In part C, what's going to happen is this. We didn't expect productivity to increase, but for whatever reason, productivity does increase. So now our technology is better than what we expected it to be. As a result, once again, what will happen to price? Okay. So it's not really that complicated. I'm sure you guys will be able to do it. And this effectively is the end of our 207 syllabus. I will update a review video later on, but for now, this is it. This is the syllabus for the third quiz and assignment.